Hello, hello. Now this time is my voice is clear. I think there was some technical glitch.
Now this time is my voice is
Yeah.
clear. I think there was some technical glitch.
It is completely fine. So here we are live back again. There was some technical glitch. That's why that live was ended. So namaskar, adab, sastyakal. How are you, students? I hope that all of you are doing very good. So here we are back again with the second portion, second part of semiconductor and devices. A very interesting, very fresh, very new topic that we have started. What we have discussed, if I will tell you, we have discussed about a term that was banned. Till now, till whatever the physics, chemistry we have studied, we have always talked about energy levels. But first time we have talked about bands, that there is not a single range, this is not a single line, there will be a band that we will be discussing about. Then we have discussed about bands. We have seen two types of band, and a valence band and conduction band. Those were the two kind of bands that we had. Then further we have seen about types of semiconductor, intrinsic and extrinsic semiconductor. What is intrinsic? Intrinsic semiconductor is nothing but pure semiconductor. And what is extrinsic semiconductor? Extrinsic semiconductor is a doped semiconductor. What is doping? Doping we have understood, adding some kind of impurities in your crystal or in your lattice, that is called as what? Doped semiconductor. Now extrinsic semiconductor also have two types. What was those two types? First one was what? Tell me. क्या था पहला टाइप सेमीकंडक्टर का? फर्स्ट वन वाज व्हाट? N type semiconductor. First type was what? N type semiconductor, in which pentavalent impurities were added. Correct? Yes or no? Second type was what? P type semiconductor, in which trivalent impurities were added, where concentration of hole pairs was greater than the concentration of electron pairs. This was the case for P type. So these kind of impurities we have added. And why? What was the our sole purpose of adding all these impurities? To increase the conductivity. From the, because normal semiconductor doesn't gives us that much of conductivity. That's why we always try to increase the conductivity, and for that we usually add impurities. Correct? This is the thing that we have already studied. Now we will be entering into the section of diodes. Now we'll be entering into the section of diodes, where the applications of semiconductor will be coming into use. A lot of theoretical sections will be there. I will say that I will give you the overview. You will be reading it from there, and in the question series I will give you the questions from where from the section from where questions will be coming. Like for Zener diode, what is Zener diode? Where will be coming to Zener diode? Zener diode questions is mostly coming. Only three simple things the questions will be asking, I will tell you. And the second one is will be the logic gates. Today I will tell you about the gates and how the questions will be coming, that we will be discussing in the question series. So is it clear? This is what we are going to study today. So be ready with your pen and paper. Let's begin without wasting any further time. So what is diode, sir? Di plus ode. Okay, from the name itself, it is a two junction device. Now what are those two junctions? Diode is actually made up of your study about N type and P type in the last lecture. Diode is basically a combination of those two kind of semiconductor. One side you connect the N type, one side you connect the P type semiconductor, and that will create you a diode. Okay, now what is the use of diode? Diode actually is used to regulate the current in a single direction. See, what is the definition? Diode is a two-terminal electronic component that conducts electricity primarily in one direction. It offers high resistance to flow of current in one direction and a low resistance to the flow in the opposite direction. This is what the work of diodes. And in starting also about semiconductor, when we were studying the sole why we use the semiconductors to control the flow of electrons. Correct? Basic reason, the first thing that we have studied was what? To control the flow of electrons. Correct? If there will be lag, please tell me. Okay, so that I can stop there and then we'll start further. Fine. So this is the, and this kind of diode is always present there. If I have to represent a diode, what is the symbol of a diode? This is the representation for a diode. This is the representation for diode. It is a combination of P type and N type semiconductor. For example, here it is. See, it is called PN junction diode. It is called a PN junction diode. I think again there's some lag. If there's some lag is coming, or is it fine? I think so, it's fine. See, here it is defined. I'm going to explain you the complete behavior of diode in this diagram. Okay, I'm going to explain you complete behavior of in this diagram, and then the theoretical portions will be available in the notes. If you want to refer that, please comment down in the comment section as notes. We'll be providing those notes, or connect to our Telegram channel. At there we will be available about the theoretical things. Here in the diagram only, I'm going to completely explain you what is diffusion current. All these directions are also important. How you are connecting the external variable battery. Then what is the direction of diffusion current? What will be the direction for drift current? All these things we are going to discuss here. Okay, let's begin. See, firstly, this is the diagram for a diode. What kind of diode it is? It is PN junction diode. What is PN junction diode? One side it is P-type semiconductor, P-type semiconductor, and on the other side it is N-type semiconductor. P-type semiconductor, whose concentration was greater? Whose concentration was greater? Hole concentration was greater, and on N side, electron concentration was greater. Okay, this is the basic thing that we have understood in the last class. Now, what will happen when you are keeping these two junctions at one place? What will be happening? And I said diffusion will start. Correct? Diffusion will start. Electron and hole pair will get attracted towards each other, and they will get what you can say, positive negative will become no charge. Correct? So exactly, can you say that will start happening? These electrons will be traveling on the N side, and these hole pairs, sorry, the hole pairs will be start traveling on this side, and these electrons will start moving on the this side. Correct? That means, can you say first thing, that electrons will start moving from the N side to P side? Correct? Yes or no? Electrons will start to flow from N side to P side. Correct? And if electrons are moving from N side to P side, can I say direct opposite to the direction of electrons, opposite to the direction of movement of electrons, I can say a current will be generated, and that current is called as diffusion current. That current is called as what? Diffusion current from P side to N side. First thing, ye to yaad rakh lo. What is the direction of diffusion current from P side to N side? Why it is coming? Due to the diffusion of these electrons and the positive charge. I will not say it's a hole. And what will happen? They will create a depletion region. Depletion region means what? It is devoid of charges. There is no charge actually present. They will neutralize each other, no? Plus minus, plus minus, plus minus. Correct? This will be what it it will be happening. Now see. So normally what we can I can say that, sir, all the positive charge and all the negative charge should neutralize to each other. Correct? This is what it should be happening. Yes or no? But it will not happen. After some time it will come down. Why? Let's understand now the second thing. What will happen? Electrons are traveling from this side, this side, this side, this side. And positive charge, that means hole pairs, are shifting from here, 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 here. I'm removing this as of now. Okay. Now understand here what is happening. Electrons are traveling on this side, on the P side. That means, can I say, here negative charges will be induced. Here a lot of negative charges will be induced, and here slowly positive charges will be induced. Here positive charges will be induced. If this is the case, then now what will be happening? Can you say electric field will be induced inside? Yes or no? If there is a positive charge induced on this side and the negative charge is induced on this side, I can say an electric field will be induced here. And how much electric field I can say? I will say it is equals to Q into E from and what is the direction of electric field? Tell me. What is the direction for electric field? बताओ कौन बताएगा? Who will tell? What is the direction for electric field? Direction for electric field is from higher potential to lower potential, that we have already studied in electrostatics. Correct? So electric field will be generated from higher potential to lower potential. Due to that, now what will happen? Some force will also happen. Let's suppose if I am taking any electron, any general electron who was there. Now what will be happening with this electron? Let's try to understand that phenomena. So this electron normally try to move in the P side. Correct? Naturally diffusion was happening. But what, due to electric field, can you say a force will be started stopping it? Now this force that will be applied in the opposite direction, can you say now it will start stopping that diffusion? Correct? Because this electron naturally it wanted to flow on this side, but due to this force, now it will not be able to move on the other side. Correct? That means, can you say now slowly this process will be stopping or decreasing also, you can say. That means you will attain a region where it is called as depletion region. Depletion region, it is a region where it is completely devoid of charges due to the recombination of electrons and holes. correct? And why not all the electron and holes pair will be shifted, that reason also I have told you. And a diffusion current will be generated. Till here it will be clear. And if there is a electrical, can I say a potential difference will also be created? A potential difference will also be created. This will be behaving like a higher potential, this will be behaving lower like lower potential, and this is called as barrier potential. This is given a term that is called as barrier potential. That is called as what? Barrier potential, correct? Now one more important thing is that till now all the directions are clear. One more important thing that you have to understand is about drift current. Drift current is actually there due to the direction of force. Due to the direction of force. See what will be happening. This force is now applicable on towards the end side. This force is applied on the end side. That is what I can say. If force is applied on the end side, this force will be trying to drift this electron on the end side, correct? If the electrons will be drifting on the end side, can I say if the movement of electrons is on the n side, I can say a current will be generated due to the flow of electrons again on the p side, and that current is called as what? Drift current. That current is called as what? Drift current. समझ आया? Is it clear? Initially, due to recombination, electrons were traveling on the p side. Diffusion current was on the n side. This was the first current. That is still there. Direction should be very, very clear from this side to this side. And due to the force that is applied on the n side, that means electrons will be traveling on the n side. That means due to that, a current will be coming on the p side. That current will be called as what? Drift current. That current will be called as what? Drift current. Correct? Now understand the next important things. Here I have told you in what are the 3-4 important things that you have to remember. I have told you initially diffusion current, it should be very clear. Diffusion current, then what is the direction of electric field, why that electric field is coming, that it should be also clear. Then barrier potential, how barrier potential is generated, very clear. Then the direction of drift current. These 4 things, if you understand about the behavior of a p-n junction, then you can understand a diode, p-n junction diode. Okay, and majorly this complete theory that is given here is only about those 4 things. You will read it out and you will understand all the theoretical things that I have explained here. Okay, so if I will talk about the stage by stage, how stage by stage it goes. First stage is when only diffusion. Initially what will happen, only diffusion will be occurring. All these electrons will be diffused with the positive charge. I'm saying again it is positive, but I'm trying to tell you about the holes. Okay, and it will get a devoid of charges, it will neutralize each other and it will create a depletion region, correct? Then what will happen, slowly an electric field, internal electric field also start to create, and due to that what will happen, diffusion current will start decreasing because an other side opposite force is also started acting. If the force has started acting on the other side, that means drift will be happening on the electrons. Due to that drift current will also increases, correct? After some time drift current will also increases. In steady state what happens, drift current and diffusion current will become equal. There will be an equilibrium situation, because what is happening, initially drift current is 0, diffusion current is very high, correct? Slowly diffusion current is decreasing and drift current is nearly, it doesn't actually increase a lot, but a little bit if it increases. And at steady state what happens, this drift current and this diffusion current will become equal. That is called steady state. Okay, at equilibrium diffusion current is equal to drift current. That will be the case. Here it is the diagram for symbol for a p-n junction diode that you always have to keep remember. This is the p-n junction diode that you just make a triangle. This triangle represents the p side and this bar represents the n side. This is the p-n junction diode, correct? Now there are 2 kind of biasing. Now sir, what is biasing? It is a new term. See, biasing is a very basic term, nothing but just the way of attaching the external potential or external battery. How you are attaching the external battery, that is called as what? Biasing. Now see, understand, if you are connected, very carefully understand here it is the higher potential and here it is the lower potential. When higher potential is connected to the p side and the lower potential is connected to n side, that means positive side is connected with positive side and negative side is connected with negative side, this is called as what? Forward biasing. This is called as forward biasing. The way of attaching the external battery with your p-n junction diode, that is called as biasing. And if p side is connected to the higher potential and N side is connected to the lower potential, then it is called as what? Forward biasing. Now you have to understand a little bit the properties of forward biasing. One property in circuit solving, I will tell you, very important. Whenever a diode is in forward biasing, it will be behaving like a straight wire. And if a diode is in reverse bias, then it will behave like a open circuit. A lot of circuit problems also solved from this concept. That's why it is very important. Star market. So now what will be the case that will be happening due to this? Originally, what was our direction of electric field? This was the direction of our internal electric field. Correct. But now we have attached the external battery. Due to that, what will happen? This point will be behaving like higher potential. This point will be behaving like a lower potential. And if I will connect this, that means electric field will be now moving from higher potential to lower potential. That means now I can say this is the direction for the external electric field. Now, can I say external electric field and internal electric field both are in opposite directions? That means both of them will be cancelling out the effect of each other. Correct? That means due to that, what will happen? This depletion region will shrink. Not a lot of electrons will be able to travel on the other side. Okay. See, as a result, electric field decreases, electric field will decrease, and hence the depletion region shrinks. Due to this, more and more because this, if electric field will be decreasing, the force will be decreasing. More and more electron and hole pair will be transferred to the other side. That means more and more current will be generated. In the forward bias, always remember the current will be more higher as compared to the reverse bias condition. I will tell you why. The net current flows from P side to N side. That is very obvious. Okay, and diffusion current will be higher than the drift current, because I have told you why drift current was coming. Drift current was due to the generation of electric field or the generation of force. If that is getting decreased, that means obviously the drift current will also getting decreased. Correct. This is one is important. What is IV characteristics? For everything that you are understanding now, you have to understand the IV characteristic as well. IV characteristic is the very essential portion now. Okay. So this kind of IV characteristics you will be having here. We call it as dynamic resistance. It will have. Just check the slope. When you will be checking the slope, what it will be coming? Delta Y by delta X, delta Y. It is what? Delta I by delta V. Slope will be delta I by delta V. Can I say it is 1 by R? And it is dynamic resistance. Why? Because it doesn't obey the Ohm's law. Because here you can see at all the places slopes will be keep changing. That means resistance is not static, it is what? Dynamic. It is not a constant value. This is one thing, very good thing that you can understand from here. Okay. Now diodes in reverse bias. What do you mean by diodes in reverse bias? Simply, when higher potential was connected to P side, plus was connected to plus, and minus was connected to minus, it was called as what? It was called as forward bias. Now, when the higher potential will be connected to N side and the lower potential will be connected to P side, that means plus will be connected to minus and minus will be connected to plus, then what it will be called as? Reverse bias condition. Simple tarika yaad rakhna hai. Now it will be called as what? Reverse bias condition. Okay. Now let's understand quickly the behavior of a reverse bias condition. What will be the behavior? Now what I am saying, this is the P side and it is connected with the negative side, and here it is positive connected with the N side. Now this will be behaving like a V potential, this will be behaving like zero potential. Correct. Now current will be again an electric field will be coming. Internal electric field, already we know this is the internal electric field that will be induced. And this time external electric field, again from higher potential to lower potential, it will be also induced into the same direction. Correct. That means both the electric fields are going to support each other. If both the electric fields are going to support each other, what will be happening? That means more force will be acting on the electrons. If more force is acting on the electrons, I will say this time the depletion region will be thicker. The external potential difference applied, the battery increases the potential barrier inside. Potential barrier will also be increases. Okay. You have to understand just the sum of the properties. As a result, electric field increases, hence the depletion region expands. If the electric field is increasing, depletion region will also expand. The magnitude of diffusion current is still very low, but even if the electric field supports the migration of minority charge carrier, the drift current is almost. Drift current doesn't affect a lot, but diffusion current will decrease significantly. Reason, because now force is a lot happening on the electron. That means the force will not allow electrons to easily come on the other side. It will not easily allow the electrons to recombine and create to move actually, because in opposite direction a force will be coming this time again. So due to that, what will be happening, this current, diffusion current that was coming due to the free flow of electrons, that will be decreased significantly, and that's why we call, in reverse bias condition, the current is in microampere. It is a lot lesser. Okay, it is a lot lesser. When you watch the IV characteristics, you will see an interesting thing. What is that interesting thing? This is the IV characteristics that you will be having. Current will be very less, very less, very less after till a certain time. But at some certain potential, current will increase significantly. Current will increase significantly. Why that has happened? This potential at which current will increase significantly, that potential is called as what? Breakdown voltage. That potential is called as what? Breakdown voltage. So there are two kind of breakdowns basically you have to understand. One is Zener breakdown, second one is avalanche breakdown. So let's see what is avalanche breakdown. What happens actually when you increase potential difference across the PN junction diode, actually what will happen, the electrons that are present there, the kinetic energy of the electrons will increase higher. The kinetic energy of increase will keep increasing, because if you are increasing potential, obviously the energy will also be increased, and that kinetic energy of that electron, it will going and collide with the other bonds also, and it will start breaking the bonds. So I can say more electrons will get free. If more electrons get free, all of those will get the higher kinetic energy, and it will make a chain. Avalanche itself is a phenomena of a chain kind of. If you know about avalanche in the iceberg, okay, there is an iceberg and their avalanche phenomena actually happens. So it is similar kind of. One electron will go and break the bond, then there will be three electrons, then they will be moving, and then again they are going to break the bond. So all of a sudden, what will happen at a certain temperature voltage, a lot of free electrons will be available. If lot of free electrons will be available, then what will be happening, all of a sudden current will also increase into the circuit. That's why we see a sudden spike into the current into the reverse bias condition. Correct. So these two things are combined way. For the reverse bias, this is the condition is complete for reverse bias, and this is the complete condition for forward bias. It is very, very important, and a lot of applications that are going to come is on the basis on these IV characteristic. Correct. That is what you have to understand. If this will be fine, let's enter into the application portion. I'm again telling, you have to read it completely. I'm going to just give you the idea, okay, that how actually it works, what are the things. You have to understand the symbol of all those things, IV characteristics, all the IV characteristics. Better if you're remembering the working principle, all these things for your board perspective, I've told you. Okay, now let's understand one by one. First one is rectifier. Now rectifier, what is rectifier? Rectifier is here you can, do you know this diagram? Have you ever seen this diagram? This is nothing but a kind of transformer diagram. Transformer, you remember, one was primary side, one was secondary side. Bindings were there in turn, input side and output side. So what is the use of rectifier? It actually converts the alternating current to DC current, AC current to DC current. Now what is AC current? AC current is keep switching its direction, and DC current is what? It is a unidirectional. So how we will be doing that? That is what you will be understanding in rectifier. Now quickly I am telling you what is the concept. Concept is for induction. What will happen if flux is changing here? That means same change in flux will be going here, same change in flux will be happening. That means some EMF will be generated, and if EMF will be generated, some current will also be generated. Correct. This is the basic concept that we have to understand. Now how that will be happening, understand. Firstly, we have to understand for half wave rectifier. Understand here, sunna the answer. This is the input AC current. Obviously you know that it is a positive, negative, positive, negative, positive, negative, and now we have to make it a DC current. That means it cannot be negative. Understand how? This is the diagram. This is the winding. This is the input side. Where is the pen? Where is the pen one? Wait a second. Wait a minute, I have to restart the system. It's not that much complicated. Simply you will understand all the applications, and the applications are actually important. Okay, just wait a minute. My voice is clear now. Yeah, fine. Sometimes system also hangs. Actually, it is. Machines can also make mistakes. Yeah, we got it. Okay. Finally, we are into the final section of 12th. Just few minutes more beer. We'll be entering. We'll be completing the syllabus. अरे यार ये क्या हो गया? We are studying semiconductor ना. कहाँ थे भाई, क्या पढ़ रहे थे? क्या पढ़ रहे थे? IV characteristics done. We are understanding about half wave rectifier. Correct. Correct. Half wave rectifier. खुल जा भाई. यार तुम लोगों को पढ़ने का मन नहीं है क्या यार? कौन बद्दुआ दे रहा है मन में? स्टार्ट क्यों नहीं हो रहा है सिस्टम? पक्का कोई तो बद्दुआ दे रहा है. मत पढ़ाओ सर आज, छुट्टी दे दो. कौन है भाई? यार खुल जा भाई. एकदम ही से हैंग हो गया क्या? खुला 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 खुला. चलो खत्म करते हैं यार जल्दी. देखें क्या है, व्हाट इज हाफ वेव रेक्टिफायर, कैसे कन्वर्ट करते हैं एसी सोर्स को डीसी सोर्स में. ये करना है. देखो फर्स्ट हाफ अंडरस्टैंड हियर. This cycle is positive cycle. Positive cycle, that means this kind of positive current will be flowing into it. Correct? That means same kind of transformation will always be happening here also. If this is positive cycle, it will also be induce a positive cycle of current. Okay. That means if this is positive cycle, that means I will say this point is at higher potential, this point is at lower potential. Correct? If this point is at higher potential, what I will say, this is a diode that is connected here at the point S1. This is higher potential, this is lower potential. Higher potential connected to P side and lower potential is connected to N side. That means what kind of biasing? Forward biasing. Forward biasing means I can say this is going to behave like a straight wire. This is going to behave like a straight wire. That means all the induced current will be simply passing from the load. That means in the output will get all the current that I have given the input. Done. Interesting is the negative cycle. Negative cycle is from here to here. This is the negative cycle. Negative cycle, now let's understand. क्या होगा नेगेटिव साइकिल में? चलो देखते हैं. Negative cycle, let's suppose the cycle of the current is now like this. That means same induction will be happening here also. That means now this point will be having a negative potential and this will be having a higher potential. Of course, polarity will be reversed if the direction of current is getting reversed. That means N now negative is connected to the P side and higher potential is connected to N side. That means what kind of biasing better? It is reverse bias. If it is a reverse bias, how it behaves? It behaves like an open wire, it behaves like an open wire. If it behaves like an open circuit, that means what is the current that is going to flow from open circuit? What is the current that is going to flow? Zero. Can I say second portion, it will become zero current. It doesn't become negative, but it will become zero. Again come to the positive cycle, same as it is, it will conduct the electricity. Then again negative cycle, again it will become zero, again it will become positive. This way it is going to conduct electricity. Now you can see the output. Is this current is negative anywhere? No. That means if the current is not negative, that means current is not changing its direction. If current is not changing the direction, can't I say that it is alternate, it is a direct current? That is what I have to do. But the efficiency of the half wave rectifier is quite low. It comes nearly 40%. You read it from your reference book. The exact value I don't remember as of now. 40% somewhere it is coming. So that's why we introduce a full wave rectifier. Now what is the full wave rectifier? Full wave rectifier, now understand. This is a half wave rectifier. All the explanations are present there. This is the final output that will be coming. Now come to the full wave rectifier. Full wave rectifier also work on the same concept, but little bit a different way. See here. Full wave rectifier, let's suppose firstly it is positive cycle. It is having positive cycle. In full wave rectifier, only change will be coming. Now a diode 1 was already there, and now diode 2 will also be present. Now diode 2 will also be present in parallel. Okay. Now see what will be happening. Positive cycle, let's suppose this is the positive cycle in which current is going, same current will be induced here, and S1 will be behaving like positive and S2 will be behaving like negative, because positive current is also get induced here. Okay. Now due to that, what will be happening? I can say P side is connected to the higher potential and this N is connected to the lower potential. That means I can say this is going to behave like a forward bias. Correct. What about the second diode? Negative. It is a lower potential and it is connected to the P side. That means what kind of combination I can say it? I can say what kind of biasing? It is reverse biasing. It is reverse biasing. If it is a reverse biasing, can I say it is going to behave like an open circuit? This is going to behave like an open circuit. That means from this path, no current is going to flow. But I can say this is going to behave like a straight wire. That means current can easily flow through the current because it was connected in parallel. That means output is obviously going to come. And due to which diode it is going to come? Due to diode 1. Due to diode 1. Clear है? अब देखो second round. Negative round. This is the negative one. Change color direction. I'm deleting everything. Now change it. Now this time what you will saying, sir, reverse the polarity. Okay, I will reverse the polarity. This will, let's suppose, negative. This will become positive. Same kind of induction will be here. Now this will become negative. This will become positive. Now what will be happening? Higher potential connected to P side. Higher potential connected, sorry, lower potential. This is not positive. This is negative. Lower potential connected to P side. That means what kind of biasing? It is reverse biasing. And here higher potential connected to P side. That means what kind of biasing? It is forward biasing. It is what? Forward biasing. Reverse biasing, that means it is going to behave like an open circuit, and if it is forward biasing, it is going to behave like a straight wire. That means this circuit is not going to open a work, but this circuit is still operable now. This circuit, and I can say easily current will be flowing from this circuit. Correct. That means this time again current will be induced into the circuit, but this time the output will be coming due to which diode? Actually, this time it is going to come with due to diode 2. Again, next cycle, what will happening? Current is going to come due to diode 1, due to again it is going to come due to diode 2. That means I can say that all of the time I have what kind of output, positive or negative? I can say simply I had the positive output, and I can say if all the outputs are positive, I got my DC current. Okay. Efficiency is still not 100%. Efficiency is nearly 81 point something percent. That you cross check, and exactly the values you can check from there. Okay, so about the working principle and rest of the things, you will be referring NCET or any other reference book that you are taking. This kind of output finally you will be having. This was the concept of full wave rectifier and half wave rectifier. Next application is of Zener diode working as a voltage stabilizer. Zener diode acting as a voltage stabilizer. Now how it works, I will tell you. Zener diode, when a PN junction diode is operating in a reverse bias situation, then it is working as a voltage stabilizer. See, firstly understand what is Zener diode. Zener diode is a heavily doped semiconductor device which is designed to operate in the reverse bias, that too in a breakdown region. Okay, it always operate in a breakdown region, and like it is very heavily doped semiconductor. This is the diagram for Zener diode junction. Just only add this and this sign. It is a representation for Zener diode symbol. Okay, so Zener diode is have 2-3 applications that you have to understand. These are the properties that you will be understanding here. First application that you have to understand is Zener diode as a voltage regulator. How it works. See, you remember what was the reverse bias region? How it looked like? Here, understand. It is always operated in the reverse bias region. This is the IV characteristic. If I will tell you again how it was working in the reverse bias region, here it will be coming, and here all of a sudden current got increased, and this was called as breakdown voltage. That was called as breakdown voltage, VB. VB it should be written. Okay. And in Zener breakdown, why this is actually happening, I will tell you. Here is a concept. I've told you, two kind of breakdowns will be happening. So this one is not avalanche breakdown. This is Zener breakdown. In Zener diode, always there is a Zener breakdown. What is Zener breakdown? Zener breakdown is due to the high electric field. After a certain time, if you keep increasing the potential, that means electric field is increasing. If electric field is increasing, a lot of electric field will be generated, and due to that, force will be a lot. And due to that, what will be happening, the covalent bonds that are present there, they will start breaking. And if the covalent bonds start breaking, what will happen? All of a sudden, a lot of charge carriers will be generated, and the current will increase all of a sudden. Okay, so this is the breakdown that will be happening. Now understand why it is actually working like a voltage stabilizer. See, what is the circuit that firstly I will tell you. This is the normal resistor that will be connected. Here the Zener diode will be connected. And the potential difference across the Zener diode is, let's suppose Vz. This is what it is always constant, and it will. And here it is a load resistance. You understand what is load resistance? What is load resistance? Load resistance is the normal thing. Your AC, freezer, cooler, whatever you want to connect for voltage regulation. It will be a some lag is coming. Oh, clear. See, when the current is less, till a certain time, what will happen? Current is very less. Current is very less. You are keep increasing the potential. If current is very less, there is no problem. All the currents will be passing from here. The required current will only be passing from here, and this voltage across the Zener diode will be fixed still. Okay. But when it have crossed a certain limit, when it have reached the potential have reached a certain limit, what will happen? All of a sudden a very high spike in the current is coming. All of a sudden, if very high spike is coming in the current, what will happen? If it is directly passed from your electronic device, it is going to destruct it. Okay, it will, what happened? Okay, so it you all of a sudden that much of current should not be passed from here. Now what you will observe, that all the current will be passing from the Zener diode. All the current will be happening. What if all of a sudden the large amount of current is coming? The Zener diode have this property that it will pass on a lot of high current from it without changing its potential. You can see at the breakdown potential only a lot of current can be passed from here. That means I can say it will maintain its potential, that is equals to Vz, and it will maintain that. If let's suppose this potential is 0, this potential is Vz, this is the same potential Vz, and this is the same potential 0. Correct, that will always be maintained. Now if a very high current is coming, it will be passing from here because it have a dynamic resistance also. So depends on the condition, it will be adjusting itself, and it will allow the same potential difference to be maintained across the load, and it will safeguard your electronic device from any kind of disruption. Okay, this is the concept of Zener diode. Now the complete theory is available here. What kind of questions, if I will tell you, in the same circuit, sometimes they will ask you, tell me the current about this R. Sometimes they will ask you the current about this Zener diode. Sometimes they will ask you the current about the load. Tell me what are the currents that are flowing. The concept that you will be using, the net current that is present, I, is equals to Iz plus IL. That means the current that is passing through the load plus the current that is passing through the Zener diode. This is the thing that you have to remember. Correct. Now second one is photodiode. Photodiode, how it works? A light, when light is falling on it, when light is falling on, again it is a diode that is present here. When light is falling on it, that means some energy is falling on it. That means a lot of electron and hole pairs will be generated into the diode, and it will create some current. Obviously, if electron hole pairs are generated, that means some current will start flowing. Now, if you are increasing the intensity, what will happen? More and more photons will be incident. In terms of photons, if light is incident on the diode, for it is a photosensitive light. If light is incident, that means I can say in terms of photon, it is energy is incident. If some energy is incident, what will happen? It will is falling on the n side and the p side. It will create a depletion region in which electron and hole pair charge carriers will be created, and due to that, what will happen? The current will start flowing. So I can say if I'm increasing the intensity, the more and more current will be flowing into the circuit. Correct? That is what now you'll be reading it. See what is the I will tell you briefly. When a photodiode is illuminated by light of sufficient energy, a new electron hole pair is generated near the depletion region. Due to the electric field on the junction, the electrons and hole pairs are swept across the depletion region because there is electric field that is already present there. Due to that, drifting will be there, and when the charge carriers will be moving, obviously they will give the birth to some current. Therefore the direction of current will be from n side to p side. That current that you know that how it is generated. If I will tell you about the IV characteristics, it also works in reverse bias condition. 2-3 things that are very important: that what is the symbol, what in which biasing it actually operates, and what is the IV characteristics. Here you can see IV characteristics. This again, it is a what? It is a reverse bias condition. That means this kind of current will be there, and you can see light intensity is greater than I3 than in I2 and then in I1, and you can see magnitude wise I3 current is greater than I2 current, then greater than I1 current. More intensity, more photons, more energy. That means more electron and hole pair will also be generated. This is a basic concept of photodiode. Light emitting diode. Light emitting diode is again a simple thing. See, a light is whenever operates under a forward bias condition. It operates under forward bias condition. This is the diagram that is important that you have to remember always. Where the pen gone here again? Okay, here it is. Due to heavy doping, concentration of majority charge carriers is very high. The majority charge carrier on p side diffuse on the, while the majority charge carrier on the n side. Diffusion will be happening because of the higher concentration of majority charge carrier on p side. The diffused electrons recombine and diffuse on recombination. See what will happen whenever the recombination is happening. When you are increasing the potential, this normal LEDs that we are using, at a certain time what will happen? Due to that energy, electrons will be moving to the conduction band. Electrons will be from the valence band, electrons will be coming to the conduction band. See, when an energy equals to the forbidden energy is supplied, when the energy is supplied, the electron in the valence band takes up this energy and jumps to the conduction band, and an electron hole pair is generated. Then an electron hole pair will be generated, and when it will be generated on recombination of electron hole pair, when it come back again to the valence band, when it come back again jumps to the valence band, energy will be liberated, and energy will be released in terms of what? In terms of photon. That is equals to energy is released in terms of h mu. That means mu is what? The frequency. That frequency is related to the, you see LED lights are of different colors. So wavelength and frequency are related from the colors. It depends on the energy, how much energy is released. According to that, different colors of light is also illuminated. Okay, that is in the form of light you will be visualizing. That is the basic. Here you can see the energy gap is directly proportional to the frequency. You will be reading this completely, and then there is a solar cell concept. Solar cell, it is made up of one, it is above side is n side, near downside is p side. When the light is falling, again it is the same kind of concept. When solar light is coming, when solar light is falling on the junction diode, what will happen? It will again create an electron hole pair will be generated. If that will be generated, a potential barrier will be created between the junction diodes, and then we connect it with the electrodes. Here you can see front grid contact, it is an electrode on the n side, and back contact, a metal electrode is connected on the p side. When those potential difference will be created across a load, a current will be visualized, that a current is started flowing through this load. This is a basic concept of solar cell. So all this IV characteristic is important. This is the IV characteristic that you will be having. Remember it, it is very important. 2-3 things that I have told you. Solar cell, what is the working principle? what was the construction, and what is this IV characteristic. These 2-3 things that you have to always remember, and all of those will be connected to the PN junction diode only. Now the final one is the logic gates. There are 5. All these things that we are using are based on the Boolean algebra. What is Boolean algebra? 0 and 1. And if someone is here, CS students, they actually study about the logic gates. They would be knowing better about logic gates. Okay, how logic gates operate, now understand here. 5 common logic gates are here. First one is NOT gate. I'm telling you the behavior of all the gates. You will understand automatically from there. First one is NOT gate. NOT gate, what is a symbol that is important? It is a triangular shape. And here it is the input side, and here you will be having the output. So what is the meaning? If you are making the truth table, let's suppose you are giving the input as 0. You are giving only the complete the concept that we are going, the complete algebra that will be followed in logic gates is only about 0 and 1. Okay, so if you are giving the input 0, that is also called as lower input. It is also given a term of lower input, and this is a term that is given as higher input. Okay, so when you are giving input as 0, the output that will be coming, it will just reverse, it will invert the input. Always it will invert the input. Let's suppose you are given the input yes, it will understand no. If you are given the input no, it will give the output yes. That's it. If you are given an input 0, it will make it 1, and if you are given an input 1, it will make it 0. That's it. That is about NOT gate. Next one is AND gate. Now what is AND gate? It should have 2 inputs always. Okay, if any input is high, output is always high. This is the definition for AND gate. What is the meaning? This is the diagram that you have to remember. This kind of shape should be there. This is the diagram for this is the OR gate, and this is the AND gate. कहाँ गया? एक second. अच्छा, AND gate इसके बाद. This is the OR gate that you are having. There diagram for OR gate. What is the definition? If any input is high, output is always high. For example, I've told you if there will be 2 inputs. If there are 2 inputs, what are the probability? That means permutation and combination that you will be having. Either you are giving 0 0, either you will be giving 1 1, either you are giving 0 1, either you are giving 1 0. Thank you. So there are the 4 possibilities that you will be having. Now let's write all those 4 possibilities: 0 0, 0 1, 1 0, and 1 1. Now what is the definition of OR gate? If any one of the input is high, output is always high. Any one of the input is high. 0 0, both are lower input, that means output will be 0. 0 1, 1 is higher input, that means output will be higher, that means it will give you 1. 1 0, 1 0, again a higher input, that means again output will be 1. 1 1, that means again the output will be 1. That means if any one of them will be 1, directly you will be having an output of 1. In Boolean algebra, how it is represented? Y is equals to A plus B. Do A plus B, 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, अब ये 2 मत कर देना है. The complete algebra is only about 0 and 1. So 1 plus 1, you will be writing 1. Okay, this is simple about OR gate. Next one is NOR gate. NOR gate, it's just reverse the attach NOT gate with the OR gate. NOT plus OR makes NOR. That means it is going to just reverse all the results, all the outputs of OR gate. For example, let's understand here. And all the NOTs are represented from a bar. If somewhere it is represented as bar, that means it is telling you about the NOR. Okay, NOT it is telling. So now understand what are the inputs here. Let's suppose again make the input 0 0, 0 1, 1 0, 1 1. What will be the normal OR gate? What will be the output of normal OR gate? 0 0 0, 0 1 1, 1 0 1, 1 1, again 1. So now what will be the output that you will be having? Just reverse it. What I have told you, you have with OR gate you have just attached a NOT. What is the behavior of NOT gate? It will just inverse all the inputs. Now what are the inputs that you will be having? 0, it will make it 1. 1, it will make it 0. 1, it will again make it 0. 1, again it will make it 0. Just attach a NOT gate with OR gate, you will be having the result. Next one, come to AND gate and NAND gate. AND gate, once you understand, NAND gate will be just making the reverse. But one important thing, what is the diagram that you have to remember? Same OR gate will be there, just attach a knot here. This small knot that is present here, this is representing a NOR gate. So diagrams are very, very important that you have to understand. Next one is AND gate. What is AND gate? This is a diagram for AND gate. It is just the multiplication. Let's again understand from the truth table, because all the questions that I will be solving is from truth table. 0 0 0 1 1 0 1 1. Multiply it. 0 into 0 0, 1 into 0 0, 1 into 0 0, 1 into 1 1. That means if any one of the input is lower, that means output will always be lower. This is the definition wise, but I will not recommend to remember the definition. Just simply understand AND gate is simply nothing but what? Multiplication. Correct. Now if you want to calculate what is the output of NAND gate, simply reverse it. I will just tell you here itself. What is the opposite of 0? 1 0 1 0 1 1 0 1 1 1 0. Check here what the outputs are. 1 1 1 0. This is the output for NAND gate. NAND gate is nothing but AND के साथ not लगा दो, just attach a not or negative sign with the AND gate, you will having your NAND gate. Clear? Basic. Easily, yeah. Logic gates questions you can easily solve. There is nothing very much typical about it. Okay. See, what question is there? How you will be solving that? Understand here. See, a logic gets shown as below input waveform A. Okay, some input waveform A is given and B as shown. Pick out the correct output waveform. You have to calculate. These are the two input waveforms are given, and here the output 4 options are given: A, B, C, D. What will be the correct output that you have to judge? Let's understand firstly what is the circuit and what is the inputs also. See, what is the meaning? Firstly understand. If it is a higher input, that means 1 it is given. If this is a lower input, 0, it is 0, it is 1 1 0 0. This is what the inputs you will be saying. Input B, what I will say? 1 0 1 0 1 0 1. These are the inputs that are available. So you can either make the truth table as well. A, B. Firstly, input are 1 1, then inputs are 0 0, then 0 1, then 1 0. इतना में तो जज हो जाएगा आंसर. Okay. Now let's understand from the complete basics. Firstly, what are the inputs? 1 and 1. And what are the gates that are available here? It is a NOT gate. It is also a NOT gate, and here it is a NOR gate. Gates, firstly you understand. Okay, gates you have to identify. Now see the inputs. 1 1, 1 and 1. After passing from NOT gates, it will become 0 0. If it becomes 0 0, then 0 plus 0, it will become 0, but it is a NOT gate. That means output will get 1. That means higher output. Which of the options in the first option is giving higher output? Option A, option C, and option D. That means option B is eliminated itself. Option B is eliminated. Now let's the second one. The inputs are 0 0, lower lower. If inputs are lower lower, that means here it will be having 1 1. 1 plus 1, it should be 1 using OR gate, but it is a not also attached. That means output will be 0. That means a lower output. Lower output. Here the input was higher. Here the output is lower. Lower na? Lower. Let's see. B is already eliminated. It is also having same. Still we cannot judge. Now 0 1. Let's rub it for a moment. देखते हैं अगला. Interesting है यार. See, let's check next one. 0 1. This one is 0. This one is 1. Now it will become how much? It will become 1. It will become 0. 1 plus 0. It will become 1, but it is you have to reverse it. It will become output as 0. Again the output will be lower. Output will be lower. The third case, this A is also eliminated. C and D are still there. Next one will be judge. Either it will be higher, either it will be lower. Third is done. Now next one is 1 and 0. This one is 1. This one is 0. That means this will become 0. This will become 1. 1 plus 0 again become 1, and the output will be again lower. 1 plus 0 again become 1, but there is a NOT gate also. That means it will become 0. That means a lower output. That means here also it will become 0. This one is this C. 1, 2, 3, 16. Here it is given higher output, here it is given lower output. That means option D is actually correct. This way, a lot of other varieties of questions are also there that we'll be watching in the lecture series. I hope that this was clear. So here your physics section is completed. So until next time, keep learning, keep growing with Tapasya. Endigo and Nendigo Nama Tapasya.